What is water's autoionization in chemistry? Imagine a tiny dance happening all the time within a glass of water. Water molecules are constantly interacting, even when the water looks still and clear. This ongoing activity is called autoionization or self-ionization, and it's a key part of how water behaves in chemistry. In this process, two water molecules come close enough to exchange a proton, which is a hydrogen atom without its electron. One water molecule donates this proton to the other. When this happens, the molecule that gives away the proton becomes a hydroxide ion, which has a negative charge. The molecule that receives the proton becomes a hydronium ion, which carries a positive charge. The chemical equation for this reaction is simple. Water plus water makes hydronium plus hydroxide. It looks like this. H2O plus H2O equals H3O plus plus O minus. This reaction happens all the time, even in pure water. But it's very slow and only a tiny fraction of water molecules are involved at any moment. At room temperature, which is about 25 degrees Celsius, the concentration of hydronium ions and hydroxide ions in pure water is about 1 × 10⁻⁻7 moles per liter. This means the pH of pure water is exactly 7, which is considered neutral. The pH scale measures how acidic or basic a solution is, with 7 being neutral, lower numbers more acidic, and higher numbers more basic. The balance between hydronium and hydroxide ions is described by a number called the ion product constant of water. At 25 degrees Celsius, this constant is about 1 × 10⁻⁻14. It tells us how much water naturally produces these ions. This constant helps scientists understand and predict how acids and bases will behave in water. From this autoionization process, the relationship between pH and pO comes into play. The sum of pH and pO always equals 14 at 25 degrees Celsius. pH measures the concentration of hydronium ions, while pO measures hydroxide ions. When water autoionizes, it creates a delicate balance that allows it to conduct electricity very weakly and act as both an acid and a base. This process is fundamental because it forms the basis for how acids and bases interact in nature, in our bodies, and in many industrial processes. It explains why water can neutralize acids or bases and why it's such an important solvent in chemistry. So, water's autoionization is a natural, reversible reaction where water molecules transfer protons between each other, creating a tiny but vital pool of ions that influence countless chemical reactions around us.